All right, guys, welcome back. So, my original plan was, if you remember, to print out some of these supports or holders, and I was going to try to make a true maglev. I'm still going to do that. I've got to print out a few more parts. But in the interim, I'm also going to build a new rotor, a very large rotor. So, and it'll be a maglev, I think. So I ordered, I got to be really careful because I've got some really large magnets here. So I bought some more ring magnets of that size. Be really careful. And of this size, I also bought, let me pull this over here because I don't want to take any chances. I also bought some 3-inch by half-inch by half-inch bar magnets. I've got 2 more of the same size 6, and I've got 4 more coming in, which will be 10. My original idea was to build a really tight rotor. This is just a prototype for fitting the bar magnets in there. And as you can see, I was going to do 6, and that was going to be the rotor that was going to sit in between these two plates here that I was going to try to suspend. But then I thought, why go little when I can go big? And so here's the template for the 10 bar magnet rotor, which will sit in there or will sit like this. So I've got the 4 more bar magnets coming in. Let me put this down. I got to be careful, these magnets. Let me put this guy over here. These guys here will fit in there. So it'll be 3 inches thick, which will fit in there perfectly. So it's going to be another beast. I got to be really careful because as my friend Magnus, what's the name of his channel now? I'm used to be G-Law, said he can hear the magnets snapping. And yeah, it is kind of scary. I also ordered some of the larger carbon fiber rods like this one. And inside this rod, to make it even stiffer, is a brass rod. It fits perfectly in there and it's capped off now because that's what I used to hook it to the bearings. Anyway, yeah, I've ordered a couple more of these, and actually I can use this for a prototype. I just got to get that piece off there. So yeah, the size comparison here is quite stunning or quite drastic. The only downside is to print a 3-inch thick. That's why I made the holes in here to use less filament and to make the rotor body itself a little bit lighter, because with 3 inches of PLA plus the 10 bar magnets, this thing is going to be heavy. And so, yeah, I want to make it a maglev. I don't know if I can actually make a maglev that's a pure maglev. I probably could, but it's going to take a lot of tinkering. And as you guys know, or if you don't know, I don't have, my patience level for stuff like that is out the window. Anyway, yeah, so I've got these, I ordered these big ones because I thought I may need big ones for a maglev later on. Oops, I've also got these smaller ones, which would work. These are the same size, I think, as these, but they're much thicker. And I don't know why I got the thicker ones. Probably because I thought I might need more power, more magnetic field. Anyway, yeah, I'm waiting on stuff to print, so stay tuned. All right, guys, welcome back. So I don't normally take you through the tedious process of doing all of this type of work, but I'm going with the capped version that I showed you before. So yeah, the magnet is captive in there, and this was the part I was waiting to print out. It's the holder, the magnet holder for the maglev portion on the bottom, and I think I'm going to have to do one on the top as well if I want to capture this rotor in a way where it's purely a maglev. There's not touching anything. I don't know if it's possible. Part of me thinks it is if I do it just right. Another part says no, there's going to be too much pushing to the side, if you will. But I think if I capture it between, so if I have a disc magnet here, one up here, both facing the same polarity, and then I put, let me get this off of here, and then I put some barrel magnets in between there pushing against or pulling, and then this guy will be pushing or pulling against that. I think if I do it in such a way, I think it's going to be really finicky and hard to do, but I'm going to give it a try anyway. If it doesn't work, I'll just move on to the larger rotor that I showed you earlier and use the maglev just in the bottom portion just to support it in the vertical realm. Yeah. All right, stay tuned. Okay, this will give you a better idea what I'm talking about. So I have the magnet in there, and when I get it to a certain point, it actually stays in the middle and doesn't float off to either side. So if I can get another barrel on this one here and have one going in this direction in the repulsive mode until it goes all the way through, then it attracts. But right now it's holding it in the center. And if I have one there and then have this one pushing up on the whole system, I think it'll work. It's feeling like it's going to work. The only issue is I'll have to assemble it with this apart. I'll have to assemble it and then put this together. Yeah, okay, stay tuned. All right, so here's a better way to look at it. You can see I'm holding it down. It's not touching the side on the top. It is touching the side on the bottom. But if I do the same thing on the bottom that I'm doing on the top, but in the opposite direction, and then either have one pushing down or one pulling, yeah, this is going to really take some finagling. So be patient. Stay tuned. All right, guys, I think I figured it out, and it's not possible. It would only be possible if I could get, which I have, but they're too powerful. If I could get, what would you call it? Half moon type magnets on either side. The round magnets aren't going to work because in thinking about it, even if this guy pushes on that and that pulls or pushes on that, it's still going to want to cock off to the side. So yeah, I think that's it for that idea. I'm still not going to give up. What I'm going to do is I'm going to try to test it in a horizontal plane because it would be easier to test it that way. Because if it will work in a vertical, it should also work in a horizontal. So gravity should have no effect on it because the magnets themselves would be holding things in place. But I don't think it's going to work. After putting, yeah, now that I think about it, yeah, unless, no, it would have to be one hell of a balancing act. So what I think I'm going to do is set up to print this guy because it's going to take the initial thing. If I wanted to do it the whole thing, which I'm not, if I wanted to do the whole thing in one print, it's like 20 hours. And that's after tuning it, using as little infill as I can. So what I'm going to do is I'm going to print 2 of these at 20 millimeters thick or 25 millimeters thick. Those are like 7-hour prints. And then print in base mode a skin that'll go around it. Something like that. So this guy, I mean, it works great vertically with a couple of bearings. So I think I'm just going to have to do that and just say, oh, well, you know, because I really don't think it's going to work the way I thought it would. All right, stay tuned. So in the meantime, while I'm waiting for those guys to print and for the other, ouch. There you go, G-Law. Got me. Waiting for the other bar magnets to come in. I'm going to revisit this guy because I remember I made this like this for a reason so that I could mount coils on here, and I figured out how I'm going to do it too. It's going to be pretty simply ingenious or ingeniously simple, or it'll just be okay. So let me get this guy up, get it put back together. I don't throw away anything. These are all the bearing holders from that pink PLA that was supposed to be red, according to the description. Anyway, it works good. Let me get this guy together so that I can take some measurements and show you what I'm going to do. Stay tuned. So anyone who was maybe keenly observant when I said I don't throw anything away and I'm going to use these probably thought, well, wait a minute, Mike, you've got bearing holders already in your vertical stand. Unfortunately, these bearing holders are real sloppy. So I'm going to use these because they're much tighter. I don't know what happened with that. I don't know if it just wore from spinning. I don't think so. I think I didn't print them correctly. So I can either A, put a piece of tape around the outside of the bearing, which is, you know, come on, man. Or 2, B, I can mount these guys. Hopefully the holes, I think the holes are identical. The mounting holes with the stainless steel nuts. So stay tuned. All right, so thank God when I printed out the bearing holders, the mounting holes are the same, which is really good. I don't know why these bearings, look at that, were so loose in there and so tight in there. I don't know if it was the filament because it's the exact same file. So maybe it's the filament, maybe it was the resolution. But anyway, let me get the other one on there. And I'll have to, I think I'll use these bearing caps too to hold the bearings in. Because before, when I had the rotor in, it just floated and the bearings would slide out, and that's no good. All right, stay tuned. Oh, also, as you guys know, I love supporting other YouTubers. So you guys are probably familiar with Hand Tool Rescue. He sent these out, or he was selling these. Yeah, Hand Tool Rescue. These big dogs. But he also did a little one. And this thing comes in so handy. I mean, you wouldn't believe it. You can see the tool marks right here where he peened it to make it tighter, which I think is really cool. This big one, there's no issue. I mean, this thing's like a freaking, you hit somebody over the head with this and you're a goner. And I opted for the brass screw. But this little guy is so cool. And I just noticed, you can see the peening marks where he hit it to make it tighter, unless I did that. I don't think I did that. But anyway, this is a beautiful tool. I also support Diresta. I have a bunch of his stuff. Got the ice pick, which comes in massively handy. Got the ice pick. I got the knife. I got his pencils, Diresta pencils. And I showed you guys the toolbox that I got from the post-apocalyptic, I can't say that word, apocalyptic inventor. Anyway, let me get back to screwing. Stay tuned. All right, so instead of using cover on the outside, I have those, I forget what these are called, but you can easily make them out of nuts by just drilling out the nut and then drilling a hole and putting a set screw. But I sprung for a little package, and it does it nice because it sits right on the inner race of the bearing, or the inner shaft part. Holds it right in the middle there. So let's get things hooked up, take some measurements, or actually let me take some measurements, see how much. So that's the top part. Take some measurements and then see if I'm going to come off of the side, the top, the side, all three. Again, this is just playing around to see if I could. I'm probably going to mount one of Sky's rotors up, coils up here to see what kind of pickup action I can get. Again, waiting for that beast to print out and waiting for the other magnets to show up, which should be, so by next weekend, I should be able to put the Beast 2 together. All right, stay tuned. So I have to try, I'm going to try the Hall sensor on this next. So I'm running it with the JL94 per usual. Again, this light is this load light. I got this stupid thing on me. This load light is actually on constant, but the camera picks up the flickering. So I jumped this coil so that it's one solid coil instead of a bifilar. As you can see, I jumped it. But I'm interested in see how the Hall sensor circuit will fare with this beast, but it's nice. All right, stay tuned. Man, I think the video shut off when I was doing it. I don't know where it shut off at, but I took a reading on the secondary coil on this bifilar, and it was producing 12 volts AC, which is not bad. I really like this little coil. But yeah, running it off of one winding is much better than jumping it. All right, let me get the hall sensor circuit and set that up and see how it's doing. Yeah, it's actually running much better. Before the you can't see them. Before the neon bulbs were lit, meaning I was getting too much back EMF. But yeah, this guy is solid for me. I know it's blinking on the camera, but it's solid for me, and it's running smooth. Oh, I have got to fix this stand I have. Ay, ay, ay. Anyway, here, let me take this out. Yeah, it messes up. The video stops every time I mess with the camera. Yeah, running it off of one of the coils. It's running 12.6 volts DC, producing on the other side of the coil about 12.5 volts AC. So that's pretty cool. All right, let me can this. And again, I'm running it off of the thicker wire. The thinner wire, I get a higher voltage reading when I use the pickup side. Anyway, stay tuned. So this is crazy. Those ceramic bearings are incredible. I turned that thing off about 5 minutes ago, and it's still going. And it will probably continue to go for quite some time because it's got a lot of inertia, because the rotor itself acts like a giant flywheel because it's so heavy. I think that's what's going to happen when I do this guy, when I finally build this guy. But this thing has a lot of inertia. It's a heavy, heavy rotor. All right, stay tuned. All right, so I set up the hall sensor circuit and it works great. I'm going to show you guys in a second. One question I have, and I don't know if it's the type of coil where I hold the hall sensor, if I don't have enough load. So I have this LED strip coming in off of the load there, and I think it's rectified. The circuit or the chip gets hot, much hotter than any other circuit I have. So let me get it going. I have to put this in the stand, and I hold the hall chip right about here, and it goes really nice. So stay tuned. All right, so I changed coils, and I'm using one of Sky's coils. You can hear it starting to speed up. Yeah, it's starting to go really fast. You really can't see the output. And you know what? The chip is not getting too hot. The LEDs are lit. Yeah, so maybe it is the type of coil. But yeah, if I hold it down here, it slows down. If I hold it right about here or right there, there it goes. Yeah, so I really like this hall sensor, but it takes a lot more setup. And of course, you can see this thing wobbling like crazy. Let me stop it. The hall sensor takes a lot more setup because I really can't just hold it like that, and I want to get the output properly. The chip still gets a little warm, so maybe it's the type of coil. This thing is really racketing. I don't know why it wasn't doing it before. I'll have to figure out a way to mount it. I also have the coil going the long way, which I don't think makes too much difference. But yeah, that's so the next thing is Waiting on the magnets. Got to print this beast out. Again, I'm going to do it the same way I did. Where is it? Where is that bad boy? What the hell did I do with it? The same way I did the other coil, which I can't find right now, which is kind of weird because it can only be in one of two places. Anyway, that's it for this week's thing. I know it wasn't very cool. I still have a lot of stuff I want to do and just not enough time. I want to get the super caps involved so we can maybe try to get some closed circuit action going. Maybe with some clever circuits, I can get some kind of closed circuit. It wouldn't go forever, but it would still go. Anyway, thanks for watching, guys. Ciao.